group that works on media technologies, and her specific topic was on the summarization of audio material. She did that work here at Philips Research in the context of her MSc work at the Technical University in Eindhoven, and I'm glad to give her the word to tell us about the great achievements that she has made over the past 9 months. The floor is yours.
Thank you very much. Well, good morning, everyone. I'm going to present the work from last 9 months under the supervision of Emil Lars, Mauro Barbieri, and Hans Vedder. The topic is automatic summarization of movies and TV series. Here is the outline of my presentation. I will first introduce you to the background of the domain, then I will present the problem. I'll propose a solution for solving this problem, and then the result of our work will be evaluated through user test study. At the end of my talk, there will be conclusion and future work. In the last few years, the digital video databases has grown increasingly much. There is thousands of hours of videos created by home videos or professional created content like movies, TV series, news, sports. It's really a vast amount of information that it's difficult to be processed, and that's why the problem for the need for video summarization has become a relevant issue. What is video summarization? It's actually the creation of a shortened version of a video which contains the most important parts of the original content. In the beginning, we performed a small user study. We interviewed some people from the high-tech campus and the Technical University of Eindhoven, and they identified the benefits that video summarization would offer. First, it's time saving, then it's catching up with missed content, recalling forgotten content, just as a base for discussion or as a base for decision what to be watched further. The applications of such system, video summarization system, are various. It can be implemented on hard disk drive recorder, media center PCs, media devices, mobile devices, or simple web services. There is a lot of publications on this topic. In order to classify these works, we propose the following set of criteria. The first criteria is the final presentation, which refers to the final result of the video summarization. There could be still image abstracts, which take key frames of the video and present them in a static way. You can see the figures below. And moving image abstract, which are again video, but in shortened version of the original video. The other criteria is the content structure. We identify structured content like news, sports, television programs, and narrative content, and then they require different type of summarization solutions. And the last criteria is the features that are used in the summarization process, which can be audio, video, or text. So where in this graph is our work? We stay here. We want to create a summary of movies or TV series on a semantic level, so that the storyline of the movie will be preserved, which differs from most of the work in this quadrant, where they mainly want to create a preview, like a trailer of a movie or a TV series, which is like a teaser for the users. But we want to keep the storyline. So, as I mentioned before, the goal of the current research is automated creation of summaries and of movies and TV series, which will reduce the time to watch, will extract and present the most important moments of the original content while still preserve the storyline. In order to formalize this problem, I have to introduce you to the structure of the video. The smallest building block is frame. It's actually a still image. Sequence of frames taken by a single camera operation is called shot in the film domain. Then these shots are grouped together by the movie creators into scenes, and at the end we have the video. But these scenes are pretty long for summarization purposes. For example, in the movie Moulin Rouge, which has a duration of 3 hours, there is only 5 scenes, which is obviously not possible to be used in the summarization. That's why we want to further segment these scenes into smaller entities and to introduce the notion of subscenes. So the problem is that if we have our video as a sequence of subscenes, some feature vectors for every subscene and a target summary duration, we want to find the video sequence of non-overlapping subscenes that maximize some priority assignment function and fit into the desired duration. How is this problem solved? Well, I'll present the steps of the summarization process now. We have as input video, script, and subtitle files. Then we analyze script and subtitles, and we extract feature which can be used later in the summarization process. After the analysis is the segmentation step. We use the shots of the video and some information that comes from the analysis, and we segment our movie into subscenes. Every subscene is assigned a feature vector, and we rank every scene in order of their importance during a ranking step. After that, the most important for the storyline scenes are selected to be included in the final summary. I'll go in a few more details. I'll tell a few more details about every step. First, I'll start with the analysis. We use subtitles. Subtitles are the textual version of the speech in a movie. They can be, you can find them in pretty much every DVD or X movie, or if not, you can extract them via optical character recognition or speech recognition. There are standard formats for subtitles. There is a few different formats, but what is common for most of them is that they have a time of appearance stamp followed by the speech lines of the movie. We parse these speech lines and extract keywords while removing the frequently appearing words like prepositions,